So in this practice, you are going to be trying to find the domain and range of different functions and relations from their graphs. So we're going to go ahead and using our correct notation, remember x's are for domain and y's are for range. Of course, you also want to be aware that these less than symbols could be less than or equal to if we happen to hit the endpoints, which you'll see examples of that as well as just the less than symbols. Okay, so be aware that this could be a less than or equal to. All right, let's go ahead and look at our first one. In our first one, we are going to find the domain, so that's how far left and right your graph goes. And so our domain for our first one is going to be from, it looks like -4 is the farthest left my graph goes to 5, 6, 7 is the farthest right my graph goes. So your domain should be x such that -4 less than x less than +7. And you have to be careful because your graph has solid points at both those places. And so your less than symbol should be less than or equal to. Now the range is going to be the lowest and the highest your graph goes. So the very lowest my graph goes is -2, -2, less than y, less than, and the very highest my graph goes, it looks like it's kind of hard to see, but that's a 4, 6, 8, 9. And again, your graph actually hits both of those, so you need or equals 2 symbols underneath there as well. All right, let's go on to our next one. This one, let's go ahead and take a look at this. Okay, this data set means that for your domain and range, all you're going to do is you're going to, whoa, that's a crazy, there you go, is you're going to list the x values that each of these points is on, and then you're going to list the y values for the range. So just moving from the left into the right, I'll look at my points that I have. So I have a point at -3 comma something, so my first x value is -3. My next x value that a point hits is -2. Then I have nothing at -1, nothing at 0. I have 2 points that hit an x value of 1, but remember with domain and range of data sets, you only list the number ones, no repetition. And then the next one would be 4. So that would be the domain of this data set. The range would be all the y values. So the very lowest is -4, then -2, and then this point's actually at a y value of 0, and then 3, and then 5. So that would be your range for this data set. All right, go ahead and try this next one. The domain for this one, even though there aren't actually points, you just look at how far left and right your graph goes. So the farthest left my graph goes is -3, and I actually hit it there. So x such that -3 less than x less than. And then the farthest right it goes is +3, and it actually hits both of those. So I need or equals 2 symbols. My range then would be the lowest my graph goes is -4. -4 less than y less than. The highest my graph goes is 3. And it actually hits both of those. Awesome. All right, let's go to the next one. Go ahead and try that one. All right, let's look at my domain. This is the first one of its kind because the farthest left my graph goes is -4, but it doesn't actually hit it there. So I'm going to put -4 less than x less than. The farthest right my graph goes, actually this arrow indicates it goes right for forever, so you can write infinity. And then also you just have to check, I can't actually ever hit infinity, so I don't need an or equals 2 symbol there. And then on the left-hand side, since my graph has an open circle at -4, that means I never actually hit -4, so your domain's all done. Your range, on the other hand, the very lowest your graph goes is 1, 1 less than y less than, and I actually hit 1, so make sure I put an or equals 2 symbol underneath there. And the very highest my graph goes, well, this arrow means it goes up for forever, so we say infinity, and you can't touch infinity, so you don't need an or equals 2 symbol. Alternatively, if you want to kind of break out of this notation and try something a little different, you could also be writing your different color there, your domain and range in a slightly different way. So another way that you could write this domain would be x such that x is just greater than -4. And then this range could be y such that y is just greater than or equal to 1. That would also be acceptable here. If you don't feel like moving on to this next yellow step, you don't have to. You can always write it how I originally did in this problem. All right, let's go ahead and move on to the next one. Go ahead and give that one a try. And now let's talk about it. So here's your domain. The farthest left my graph goes is -infinity, because the arrow means it goes forever to the left, and it actually goes forever to the right too. So right off the bat, I'm going to go ahead, and this is one of our all x values such that x is in the set of real numbers, and we have some notation to help us shorten that. So that's awesome. Let's look at our range. And for the range, the lowest my graph goes is -5. It's not going to go any lower than that. So -5 is less than or equal to, because it actually hits -5. And then a y value less than up forever, which means infinity. Or again, if you're trying to figure out the shortest way to write everything, this one, another way to write this inequality, so all the values between -5 and infinity would be all values that are just straight greater than or equal to -5. That would be the other way you could write that one. All right, let's go ahead and try this one. For the domain for this one, you'll notice that your arrow goes forever to the left and forever to the right, so x such that x is in the real numbers, all real numbers. And then we'll notice as well for this one, it goes forever down and forever up, so your range is actually all real numbers too, which is awesome. All right, this one's a little tricky, but go ahead and try it, see if you can do it. Okay, now let's go ahead and look at our domain here. So looking at the domain of this graph, you look at, well, the arrow means it goes all the way to the left, and then I hit every number on the graph, and then I go all the way to the right, at least for my x values. So my x is going to be all real numbers, my domain is, excuse me. But my range is going to be very specific. So your range for this problem is going to be like, I don't hit any y numbers that are in the negatives. I don't hit any y numbers actually below 1. And I don't hit any y numbers in between 1 and 3 or above 3. So really, I only have 2 y values that my graph hits. And one of those y values is 1. The other y value is 3, and so then your options for your range are very specific. Y equals 1 or y equals 3. So if you have horizontal lines, or you'll see in a second when we do vertical lines, you could have equal signs or inequality signs in your domain and range as well. And it just helps it to make it the fastest and shortest way to write it. So there you go. All right. Go ahead and try this one. So the domain for this one is going to be all the way to the left, but now we have to look out because I got like a random hole here and I got a hole over here, so we just have to make sure we're worrying about those or considering them when we're writing our domain. So for this domain, it looks like it goes all the way to the left, so we would say that our smallest value is -infinity. It's less than x is less than. The farthest right it goes is 2. And it doesn't hit 2 because there's an open circle there. But one other item you have to put in your domain is that x is not allowed to be -3 because we have a hole there. So this one's kind of a tricky domain because you're kind of putting a couple of conditions on it. So our domain goes from -infinity to 2, but x is not allowed to be -3 either. Okay? When we look at our range actually is going to be a little simpler, which is nice, because even though there's an open circle here at this y value of -2, there are also points at -2. So that's actually the lowest your graph goes. So -2, less than, and you actually hit those points, less than or equal to y, less than, and then your graph goes up for forever. Even though there's a hole over here at a y value of 1, the graph does cross it over here. So it goes up forever, so you can go to infinity. All right, don't think we have that many more. Let's take a look. I kind of prefaced the vertical line, so go ahead and see if you can use what we did with our horizontal function or relation earlier to apply it to these vertical ones. All right, let's talk about domain. So our domain is all the numbers that your graph hits that are on your x-axis. And so we don't have any graph that's hitting over here, over here, over here. We have graph hitting at -3. Then no graph anywhere on your graph here, here until 2. And then nothing after 2. So actually your x values are very limited here. It's either x is -3 or x is 2. Those are your domains. Your range, on the other hand, goes forever down and forever up, and it hits every number in between. So for our range, we could say all real numbers. Y such that y is in the set of real numbers. Lovely. All right, go ahead and try this one. Okay, let's talk about domain. So our graph goes forever to the left, forever to the right, hits everything in between. So we would say all real numbers. And then our range, this is one of those very specific ones where the only y value that my graph hits anywhere on here doesn't hit any negatives, doesn't hit 0, 1, 2. It does hit 3, but it doesn't hit anything above 3. So y such that y is only going to be 3. Excellent. All right, here we go. Another data set. Go ahead and try that. And the friendly reminder for data sets is that you're just listing the x values and y values. So let's go ahead and list the x values of each of those points in numerical order without repetition. And then let's go ahead and do the y values for my range. Careful here, this point is at a y value of 0. And then we have 2 points that are at a y value of 1, but we only list it once. There you go. So that's your range for that one. All right, and here's our last one. So our last one, go ahead, try that domain range. All right, goes forever to the left, and then it comes until 4. So for our domain, we'd say -infinity, less than x, less than 4. And we actually hit 4. You can never hit infinity. And then our range, oops, would be y values such that the lowest my graph goes is 0, a y value of 0, and I actually hit 0. And then the arrow means up forever, so positive infinity. And then again, if you're trying to get away from having to write your infinities and negative infinities, we could always write for this one x such that x is just straight less than or equal to 4. Oops. Or range, you could just say all y values that are greater than or equal to 0. You never have to use the yellow versions of these. You can always write it using the white ones. All right, if you have any questions, let me know.